runtime prediction methods more sustainable for other researchers. So that will be the first talk, and Julita will follow in the steps of workload formats and will propose some modification to the workload format. So I think it will be perfect. It will have perfect connection to what Dror was actually talking about. So if you are ready.
Everyone can see them?
Yeah.
Okay, so the switching works also.
Perfect. So the floor is yours.
Thanks. And hello, everyone. I'm happy to present my idea for a collection of job scheduling prediction methods. This work is up to now only an idea. Therefore, this paper was submitted as an open scheduling problem, not as a full paper. The presentation is quite short, but I hope for a lively discussion afterwards. So what is the motivation for such a collection? First, HPC systems require accurate job runtimes. That is something that we all know and has been done by many scientists for decades. So there are different reasons why we do job runtime predictions. A common reason is, for example, just to predict the job start times of queued jobs. Probably there is a limit in the power budget, and we want to stay in within that budget. Also, the load distribution to avoid any kind of congestion on the I/O or network or something like that. And for example, in my case, I did job runtime predictions to improve the data staging for jobs, so that the data that is needed by a job is on the right time at the right spot. So at the end, I also did the job runtime prediction. But also another reason is just simply to increase the system utilization. So there are many publications in this area which focus on slightly different aspects, but all of them do in some way a job runtime prediction. So this is basically motivation. So with the idea of such a collection, I want to achieve different goals. First is to create a collection of the methods and also the source code so that we can repeat the work and also compare the results. And this would just help every other scientist to compare his new approach with the existing ones. And of course, with this, we help to, or the idea is to improve the sustainability after the publication. In my opinion, we need three things for such a collection. The first are job workloads and metadata. Second are metrics and classification for the approaches. And the third one is just at the end, creating a repository, a website basically, and putting the results on them. So for the job workloads, there are very well-established repositories like the Parallel Workload Archive. We heard now a keynote about that. Also, the JSSPP website has a very good workload archive. These are very well established, and there is basically no need to create another one, so we can just stick to them. Additional metadata that are not supported by, for example, the Parallel Workload Archive with the standard workload format can be published with companion logs, which is already done on this PWA. So even if we want to offer more metadata that is available through the format, we can do it with companion logs. But there are also sometimes papers which evaluate privacy-sensitive data, which can't be published. I also did something like that. And I was not able to publish the workloads after the publication. So the question here is, what should we do with such workloads or such papers or approaches that use metadata that can't be published? Should we accept them or should we just ignore them, basically? Most important for such a collection is which metrics should be used to measure the prediction accuracy. So there's a lot of metrics like root square, the mean absolute error, median absolute error, or standardized error, or the percentage error. Should the deviation of the accuracy be measured in seconds, in a percentage, or in a normalized value? And if the model for this wall time prediction is machine learning based models, so does it need a training? And does it support something, for example, like partial fit, or does the model have to be trained over and over again? what's the solution for a cold start, or should we count over and underestimates? Are they important to measure? So the question here is, which metrics are useful and important, and which should be always measured for any kind of solution? As the third important part, like mentioned before, is the website. My idea is that I could collect only freely available solutions so that we can use the source code. Of course, that website could be used for further problems, like mentioned right before my presentation. There are a lot of other issues, or for example, the node allocation prediction that I made once. So there is a lot of things that should be collected, but there are already websites, and I don't want to compete against them. It's more like for all the things that are not mentioned anywhere else. So an initial website is already available on GitHub pages. It is not much content on that website. I just wanted to discuss here with the community if such a site makes sense and how should it be designed, or what should it be present, before I waste too much time into it. So the conclusion of this presentation is that I'm proposing a repository for HPC job wall time prediction. This is only a starting point, and there's a lot of feedback needed to make a good repository. And I don't want to replace existing repositories and archives. It's more like that they could interact somehow, or more like linking to each other. I want to improve the comparison and sustainability of the existing solutions and of any kind of further publications. Further methods and results are going to be added to this website. At the moment, it is just one simple wall time predictor that I just tested to have any kind of content on that website. So the plan is in the next weeks and months to just add more and more content to this site. So thanks for your attention, and I hope I can get a lot of feedback from you people if such a thing makes sense, and how should it be done to meet the to be accepted by the community. So thanks.
Thank you. So it's an open problem. Let's discuss this issue. I made some comment in the Slack that because I was also dealing with runtime predictions, and absolute errors were not so useful for me when it comes to backfilling, because it hides the fact if a job was overestimated or underestimated, and underestimation is somehow critical for backfilling compared to user estimate, which is the upper bound. So for me, those metrics based on absolute value were not so much helpful. That's my take on this. And I would like to see some collection of runtime prediction methods, because that's something that I'm actually working on here at CESNet in our system, because we want to make the scheduling more predictable, let's say. And yeah, the user estimates are not they are not accurate, and all predictions that we do are somehow pessimistic. So it would be better if we have some more accurate predictions, and have a set of well prepared I don't know, plugins or something like that, implementations basically, so that we can, because we have simulators. Yeah, I have a simulator. I'm testing new setups, but yeah, those predictors that were used in the literature, you know, if it's some machine learning, it's basically, it's not reproducible for me, because it's not very common that you get something that you can use out of straight from the box. So yeah, I like the idea, but it will be tough work, I guess.
Yeah, I know that's a tough work, but I had my own experience was so I submitted 1 or 2 papers where I tried to do some wall time prediction, and what was a little bit, so it was also one of the first paper I ever submitted, and I was a little bit confused because no matter which metric you choose to show how good your predictions are, one of the reviewers always asking for another metric, or just always ask, why have you chosen this metric and not 5 other metrics? And the second time I resubmitted that paper, I have chosen the metrics here at once, and then the reviewer asked why I didn't. It's a little bit annoying, and I have to be honest. I also did after I published my paper, I was proud of it at the time, but I visited other conferences, and similar work was done always. So it was like repeated work always, because there is no such a central place where you can just go and look for a solution or just compare your solutions. There are a lot of papers. Of course, since 20 or 30 years, I always citing the same papers, but I'm missing the piece of code that I can just run against actual workloads or something like that. That's the reason why I thought it could be a good idea for such a collection. And then, of course, which metrics do we choose? Because I guess all of them, because if we just don't use any of the metrics, someone will complain why we haven't used it.
It's somehow similar to what Dror was saying, that with the static workload, wait time measurement is a good comparison. But if you start to adapt to your workload and the scheduler is somehow more capable, then actually the wait time or response time or whatever can increase, which would normally indicate that the scheduler is bad, but this is not the case. So yeah, choosing the right metric was always a nightmare for me, because as you start to understand at least slightly how the system behaves, you often find a problem in what you were actually measuring. I mean that your metric is not good enough, but you're not aware of better one.
I think you're going a bit off track here. The metric is not the important thing. If you want a repository of runtime predictions or other predictors, then you should just go do it. Create a repository for predictors. And anybody who uses it will use it with whatever metric they want to use. I mean, you can contain data about things that people have done, but it shouldn't limit in any sense what you are doing in terms of creating a repository. And when you create a repository, there are 2 important things. First is that you should be willing to invest the time and effort, and then you create a community resource, and then people will use it. You ignore the reviewers; they don't really count. If you believe in it and if you make a good design, then people will use it, and then it becomes a resource. So that's how the parallel workloads archives work. And the second important thing is, the most important thing maybe that you need to do is to define the interface. So you say, okay, you're going to define an interface for a module that does predictions. And then you are going to create one such module and then another such module, and you are going to invent other people who create such modules, and you're going to create a repository. The important thing is the API. And the API initially is very simple. It's just that it gives you sort of the basic data you have about the job. For example, who the user is, what the requested processors are, what the requested runtime is, and so on. And you just give it to the module that does the predictions, and the module accumulates data over time and uses that to make new predictions. And so you have 2 functions. One function is give the module some data, and another function is, for this job, what is your prediction? Now, later you can add more things to the API if you want more sophisticated things, and you want, and that can be part of a discussion, or that can be part of, you see somebody else use something and you say, hey, that's a cool idea, I'll add it to my API. But you have to initially define, and this is the most crucial thing, is to define a good API, and then people will start using that API.
Okay, so you're telling it doesn't matter which decisions or which metrics, so just start with something and increase the things later and later.
That's my suggestion.
Okay, so basically it doesn't matter which metrics I choose, I should just start somewhere.
I'm not quite sure if I agree that metrics do not matter. For example, the flurry behavior that you described, Dror, means that if you are just averaging job completion time, turnaround time, they will be highly influenced by a single user, for example, right? So,
but if you don't know it, then I mean, we did that for. I mean, we just discovered flows. It took a long time. We were using these logs for like more than 10 years before we discovered that they include flows, because nobody ever thought of looking at for that. Yeah, because why would you look for that? It was a really strange discovery. So it doesn't mean that all what we did was useless. It wasn't as good as it could have been if we had known about the flows and cleaned them out.
That's an interesting argument, but I guess what you are saying is that it's an iterative process that we learn and then we loop, we feedback. But I think to Mehmet's point, having the ability to more easily compare with previous works would really give a huge boost to the area. Narayan had to drop, but he was like a big champion of the idea of a call for problems, right? We had this idea. It has not worked so far, but it doesn't mean that we should give up, which would be the idea that JSSPP is open for submissions of problems and evaluations, like the framework that we were discussing a little bit in Dror's presentation, that people could actually plug in their scheduler that they are evaluating and sort of easily compare who is everybody else. And like the methodology that Dror outlined is a great one. I think that would create in our area the ability to reproduce and easily compare what you are doing with others, which to Mehmet's point, right? I mean, we would give hope to get out of this loop of doing more repetitive work. I mean, each work individually is cool and interesting, and it's nice, and but as an area, we could be, as a community, we could be progressing much more quickly if we were able to coordinate our efforts around that.
Yeah, so this repeating or comparing the work is sometimes hard. For example, in the example of this job wall time prediction, there is not much code going around. So I myself implemented the built-in predictor from Alea just to compare the results without using the whole scheduling software that Dalibor has. So I would be happy if someone points me to or could send me his solution or his piece of code, or just publishes somewhere and just points me to where the code is available, so I could compare them or just run them on my on my systems and then check what the result is. So at least that would be nice, but there's almost nowhere code available. Always, of course, they are published in papers, but actually having just the paper or the piece of code is a huge difference in my opinion.
Yeah.
But I totally agree with Wilfredo. It would help to compare just the results. If up to now it's always just developing code and pointing to a paper and showing that we have or that the owner's solution has a better result or something, but it would be different if you could have the code and run it actually.
Yeah, so I use the opportunity to put a plea to the community that people interested on that, please reach out and contact us. Maybe, unfortunately, I'm not in a position to drive that because of like my work day, the things I'm doing for work. But if anyone has interest, contact. Maybe we have ways to help. I think it would be really cool to, develop a framework and experimentation method that becomes common.
Yeah, I would just take the suggestion from Dror and just start with something and it could just develop over the time, and probably next year we would have a ready-to-use kind of framework for this. Who knows? I will just start with the work, I guess. I promise.
If I may make a suggestion, would it be possible for GSSPP organizers to encourage authors to provide experimental artifacts when they submit papers? This is something that is now required for conferences like SC and also Europa and Europe. So if you submit a paper and you want either an extra badge on your paper proving that you made the effort to make the code available and make the experimental material available, you are somehow rewarded by a small something in plus for your paper. And this way, it may solve part of the problem of that Mehmet mentioned, that, okay, you have the nice results in the paper, but you want to reuse them or adapt them or extend them, you have to redo everything from scratch, basically. So yeah, maybe it can be an insight from the conference or something from the workshop. I don't know which way you will do that, but
yeah, we have this call for problems. We have this call for problems, Fred, open for like a couple of years. I would love if someone feels excited about it. And as I said, maybe we could help, like reach out to me or Dalibor or Narayan or Gonzalo, and let's see how we can collaborate to make it happen. But we need to find someone who thinks can drive that can be a really interesting project with wide benefit for the whole area. It's like a leveraging project.
Will someone has to check those those codes? Yeah. Okay. I agree. That's common nowadays. Yeah.
At the same time, maybe we can just start indexing contributions, right? Like there are many papers that they already come with open source publications on those modules or generators or simulators, and there's actually the stuff, but it's really hard to find because you have to find the paper, and then from the paper you have to find the link. And maybe we can just start by publishing like an archive of the open source contributions associated with the papers. Like, I mean, just talking about my own work, I remember a paper in this workshop 2-3 years ago, and part of it was like open source contribution for simulation and for model generation. And what ended up happening is people, first, when you present the paper, usually you don't have the permission to publish it yet. So you have to wait for a bit, and then people have to contact you, and then you have to contact the place like, okay, now it's available. And maybe having a place to consolidate links to like repos and things like that would just be helpful, just as a start point.
Yeah, I think in GSSPP we can provide that in our site. That would be easy, yeah, right? I mean, we should try and come in forward to make this easy to, because I agree with you, Gonzalo. If we could kickstart the process, Drawer was very successful to do something equivalent for the logs and even for models. So
yeah. Okay, I think we can continue during the break. But now it's time to introduce Julita, who will present her talk on extending standard workload format. So
okay, let me share. Sorry, I am missing the button. Okay, can you see my slides? Yes?
Yes.
Okay, thank you. So my presentation is also a little bit, I will not say philosophical. It's a proposal, and of course it's open for discussion. And my plan is not to get an answer if you like it or not today, but I think it will be a good idea to open the discussion, no? In the same way my colleague did before. So what I will present you is the motivation for this proposal, one slide with the list of fields in the standard workload format. I assume all of us, you are familiar with that, but I think it would be good just to summarize the specific proposal for the modular workload format and just few use cases that we also had in the paper, and just one summary with the idea at the end, okay? So independently of the way we use for simulation, we need realistic. Maybe I should put in red realistic, because after the talk from Dror, it's not so clear what realistic means. But independently if it's based on models or traces, we need something for job scheduling evaluation, more static, more dynamic. I have been using workload traces and also models for 20 years, okay? So for me, the good thing of using traces generated by a model or from a supercomputing center is that allows a deterministic input that then is easy to compare. Not sure if 100% realistic, but easy to compare, okay? And having standards, of course, like the standard workload format it was a perfect idea, no? But it was proposed 30 years ago. So it was more or less at that point there were homogeneous systems. The resources was basically CPU memory, and there was some basic, I would say workflows, but I'm not sure if the fields in the trace files were workflows or they try to reflect this user behavior Dror has been presenting before, okay? So our problems comes from our participation in the DeepES project. It's an European project. So we were talking, it's a project focused on modular, on the concept of the idea of the modular architecture. So there were some requirements for our scheduling simulation not covered by the standard workload format. So in a modular architecture, basically, we have n subclusters. There is a picture later. They are not like they are not like partitions. They are something a little bit more complex because these subclusters are supposed to be different architecture, but the idea is they are managed by a single scheduler. It could be even something more complex, like a scheduler delegating to the different sub-schedulers or something like that. So in this architecture, we have new, not so new, you can see hardware resources, but they are typical, like GPU is really, really standard. We have other things like network attached memories. There were new topic of interest like energy, power, types of dependencies. We were dealing with workflows with specific delays. We were also taking into account some runtime, job runtime characteristics, some metrics affecting the scheduling decisions, and some different, a little bit more new or more updated types of job configuration, no as monolithic as just looking at a job like a box, okay? But all these topics are not really new. They have been there for the last 15 years, okay? So this is what we call a modular architecture. I will not explain here, but just to show you what's the idea, having different, like a booster, a typical cluster, which is a really, really standard specific components for data analytics. So it's a little bit more different than only partitions, okay? So for the different topics I have mentioned, we were at the beginning of the project, we were analyzing how these ideas are reflected in schedulers, and in the project we were using SLAM. So in the paper, we have tried to not focus only on SLAM, but I think it's a good reference because it's a widely used scheduler. So for instance, the concept of the modular architecture is not exactly the same, but we can mimic the concept of partition, or flags like cluster already exist in SLAM. So, of course, GPUs, for instance, concerning hardware resources, but there are other things like bus buffers, which are more generics. Other topics interesting, for instance, related to power, frequency are already included. There are like power profiles also in the SLAM. So there are a lot of types of dependencies for workflows. Concerning runtime information, that does not apply in the case of a scheduler, but it's really practical when doing some simulations. And there is also the possibility to specify different types of configurations. So for instance, as Lorm introduced, I think it was 2 years ago, the ideas or the concept of heterogeneous jobs, okay? So you can run a job being composed of different binaries in different partitions or modules or subclusters or whatever name you want to use, okay? So in the standard workload format, I think you are probably experts on that standard. So the idea is having a simple text file with single line per job. Basically, I think everything or mostly everything are numeric fields, really easy to parse. There are default values and so on. So you can describe the system using some headers. And basically, you can find these sections, no? Some details of the identification of the job, some timings. There are some values that are not input, are output, like the wait time, for instance. One section for request, one section for the allocation, which is also output of a simulation or reflects the execution when it represents a trace from a supercomputing center, and some submission characteristics. No, our proposal is to, or what we want to bring to you is the proposal to update to current trends in architectures, scheduler options, types of jobs, and so on. Okay, so there has been 30 years since the proposal. So I think at least we should consider to extend, even in the format it says it was not extensible. 30 years is a lot of time. So maybe not today, but we can discuss on that. And the proposal was to try to incorporate what we can widely access, for instance, the incorporation of GPUs or things like that, no? And also to take the opportunity to add some fields that could be flexible and can be used for different purposes, like, for instance, adding something to later identify the job with some runtime details that can be used by the scheduler also. So our proposal is to extend and profit the same ideas that were very good ideas. So having headers with clusters, in that case, it will be with the module, the description of the modules, having one row per unit of allocation, but in our case, is like a sub-job, is what we call a job components, having dependencies. And we also, at the end, for instance, we have included, at the end of my presentation, I have included the link to convert all the standard workload formats to the modular workload format, because there was some of the reviewers asking about that. So it was really simple. I have included the link in the presentation. So in fact, it's really easy because it's a parsing of one text file to another one. So some details that were not clear in the paper is, for instance, what is a modular job? So a modular job is something a little bit more complex than this monolithic jobs we had till now. So it could be one job with one component. So it's what we understand by a traditional HPC job, but it could include multiple components or multiple steps independently of the terminology we want to use. So they can be consecutive, they can be in parallel, there can be some overlapping in the execution of them, they can be executing in the same modules, different modules. So for instance, in the paper, we include these examples. No? So this is the classical execution. You can see that like a single job, and that will be okay. For instance, that will correspond with S-batch in the case of Slurm with 2 SRAM inside, so one executed after the other. So for this use case, there is no need to change anything. But if you have something like that, having everything together here like a single job, when one part is executed in one partition or one module and another one in another partition, so it's good for the scheduler to be able to know these details and not seeing like a black box. So some examples with dependencies, no? For instance, in our proposal, there are some scheduling events where the job can raise some changes at runtime. So in that case, there was the execution of our flow. Well, at runtime, we changed the type of dependency, and then it was executed differently. So these events was an API. So the API was specific for our scheduler, but the good point is that this scheduling event was able to be introduced in the trace, okay? Or just some more, let's say, already existing types of dependencies like these ones to express that after a few seconds or whatever number of seconds the other job has to start. So some details about our proposal. So one thing that needs to be included is the way to identify the jobs. So we were following, our proposal was based on the one used in Slurm. So they were using a single job ID when there was an heterogeneous job, and then with an offset generating the component ID. So in that case, what is a unique identifier is the component ID. So it can be seen as independent jobs also, but then you have a same number aggregating or making clear that all these components belongs to the same job, okay? So the set of fields that we have really quickly is we have some fields that belongs to the identification of the job or the modular job, like the modular ID, the total number of components, the name, the user groups. So some of them are exactly the same that was already existing in the standard workload format. Some fields related with timings, again, is more or less the same. Some fields which are specific to the different components that can be part of a modular job, okay? There is one section that is an input with the resource requirement. So this is a proposal. Of course, we can always see that there is something that is missing or something that is not needed. So for instance, I have included in the presentation the requested GPU freq, which was not in the paper, and this is what is in red, because I think we missed to include. So we add something about CPU frequency, but not GPU, and that's typically already existing in the schedulers. Or there was a comment in the reviews about the partition, why a name, not a number. I think using names is not a problem, but it will be also not a problem using numbers for that, okay? We propose, for instance, to add something like extra requirements, and then here there can be mostly everything included, because our proposal is to use regular expressions. And again, we base that proposal in the flag already existing in the Slurm that is a constraint, so you can add ands, ors, etc. It's really, really powerful, okay? The section for resource allocation will be, as in the standard workload format, to reflect what you were using. So it's an output. So there are the details, basically the same details that in the input, but exactly the resource you have received, okay? And in the case of dependencies, I have put that in red because I think I had the feeling when we were doing the paper that the think time was one time we can use to express the workflows. But after reading, and also I think based on what Dror was saying, I think this think time, and maybe Dror will correct me, was there to reflect the user behavior and not to specify workflows where one job has to start in the other because data dependencies, for instance. But it could be reused if needed, okay? So you have here some of the examples that you can also find in the paper. So this is a single trace, and I have marked a little bit the different use cases. No, so this is the simple one. This is a traditional HPC job with a single job with one component. So there is nothing special here. It is the normal one, would say. So if you have this use case, for instance, that will correspond with these two lines where you have one after the other, so the two belongs to the same job, but there is nothing especially. And in fact, in the standard workload format, we can just aggregate like a single one. But you can also reflect something like that, okay? It's an heterogeneous job, for instance, is this one. In that case, we have included also just an example that we were requesting some FPGAs running in different partitions, and that was identified the different jobs. We have, of course, simplified the number of columns because, as you can see, the proposal is really, really big. For instance, this one, the case for the dynamic dependencies. So we added dynamic here, and it was specified that it's after the component number 6. So this time is also included in the trace, but just for space, I have not included here. And finally, this one will allow us to, for instance, change the type of dependency and to reflect this kind of workflows. So we were using that proposal in the deepest project. And what we were proposing in the paper was the last version, because when we were working, especially in workflows, we were identifying that things like these scheduling events were needed to be passed as an input for the scheduler. So this, for instance, this is the particular section for these scheduling events. Okay. So just to summarize, the idea was to bring that maybe we could revision the proposal to take profit of the new or the potentially new data that could be in workloads, because the users are using in these flags with the new schedulers. I maybe to agree on adding some fields and to make it flexible to have a new format for 30 years, for more 30 next years, okay? So in our particular case, we were forced to do a new format, so we think it was a good idea to share with the community and see what do you think. If you like it, maybe not to accept as it is in the paper, but to share with you. Okay. As I said, most of these fields were based on slurms because it was our reference in the project. So the good thing is we could reuse all the already existing traces, because we did that in the project. We were not creating new traces. We were just adapting, and the options that were not there, we were creating synthetically with some new tools. And here you have the link that includes this simple parser to convert the standard workload format to the modular workload format, where of course all the values that are, all the fields that are not in the standard workload formats are set to null values. And that's all from my side.
Thanks a lot. Yeah, I agree. I actually did similar things in the past when I wanted to do more, let's say, realistic simulations. For example, those, how to put it, those more complex job parameters. It's not only CPUs multiplied by time. It's not a rectangle. It can be several rectangles on multiple nodes. What I also miss during my simulation attempts was some proper description of the hardware architecture. I mean, like, there is always in the archive there is some simple description how the system was composed, but as we have a standard for describing jobs, it would be nice to have some at least basic notion of how to describe machines, because then when you want to improve or you want to compare how far your simulation is from the original behavior, it would be nice to have at least some starting point, like the system had these queues and there were these constraints and stuff like that, just to get some better understanding. But
you are not referring to hardware, to low-level details of the hardware, no? So
No. Just okay. I mean, in the
a little bit more, no, of details of the configuration. You mean?
Yeah. Because now you have sometimes you have details about queues, sometimes you have details about I don't know, number of clusters and number of CPUs per node, but often in the system there is some limit. For example, that this queue can only access half of those nodes or something like that.
Yeah.
Some operational constraint.
I have to confess that we never compare with the original system because it's very difficult to compare. Because
sure it is.
I mean, what we do is we implement our reference typically is the easy backfilling. So we have that in our simulator, and then we make some proposals to improve the easy backfilling. But the reference is not the original system; it's that trace with that given policy, and then we compare with the reference is not the original. The reference is our simulations with the easy backfilling.
Yeah,
there are many details.
It may not. But I also mean in the papers that are using those workload loads, because, for example, I studied a lot of papers from this workshop that are showing some behavior on, I don't know, CTC workload, and I see these, I try to replicate basically the result of the paper, and since I have complete information about the workload, but I have no idea how those researchers set up the simulated system. So then it's basically guessing what was their setup, and it's
yeah. In fact, in the previous presentation, I was thinking that this idea to collect at least the links of the people that we agree on sharing our tools, our simulators, everything, it would be a very good idea if it was possible to to put together with the parallel workload archive, as you were suggesting before, because it's true that when also the reviewers, no, when you send a paper, they say, why you don't compare with whatever proposal? Because I think it's quite very, very difficult to reproduce the specific proposal. Sometimes you need to create, again, a new simulator from scratch. That's impossible. I mean, that's not realistic. So if at least the simulator was, or the binaries or something, and probably that comes from the comment from Dor, no? That the most important thing are the APIs, no? To be used to put together things that originally we were not together. That will be really good for the community to be able to really compare with the others' algorithms, other ideas, and not having to repeat again and again.
But I have to agree with Dalibor. I also had the problem that I tried to simulate some machines. They had some topology awareness in their scheduling. And so the partition and the nodes were the same, but the scheduler behaves completely different if there's a topology, and then it should be take care of it at the scheduling. So it's almost impossible to repeat or to get close to the real world if this is not known. But I have also to say the SWF format, SWF, is very simple and good to parse. So it's the only thing I would change immediately is the delimiter between the fields from white space to comma. That's the only thing that I would change. Yeah, that's a little bit annoying to parse.
I think that's a good opportunity.
I couldn't understand you. Can you repeat?
Yeah.
So I think that could be a good opportunity to use like those two cases, and like Julita Finish, who is a link to open source stuff for her simulator. Maybe we could start this as a seed to see if we can change the situation. We were just discussing this very topic, right?
So, for instance, we have a BSC as LORM simulator, which is also open source. We have included the link in all the papers, but it's just a link in a paper. So I think it's a bit lost. So it will be good if we'll be more busy. This kind of tools has more visibility in the webpage of the conference on some place, because we have shared many times the link. But I think it's just one line in one paper, and no one sees that link. And it's a pity because there is a lot of hours spent in this work. So, for instance, our simulator uses a standard workload format as input, so it could be used by any other researchers. It can be additional contributions because it's open source.
So Dalibor, what do you say? Let's create like a page in the site and start collecting those things as a starting point, right? Because I agree with Gonzalo. If we do a starting point, it's easy to iterate than if we sort of try to think on the perfect solution, which is hard to do.
Yeah, maybe people contributing can just add the link and a simple example of how to use it or something like that. It could be a README, but that will help to use it, and maybe not to reuse the word, but at least to compare things like that. So that will help for sure.
And I think a section on simulation tools will be easy to populate, because among the 18 current participants to the workshop, I think there are 6 different developers of different simulation tools. Gonzalo, Rodrigo, myself, Pierre-François, you, Julita. So I think it will be easy to start a section and have several links in it from the start. So.
Sure. In fact, in my case, for instance, it's not myself, it's Marco, the other author of the paper, and Marco is finishing the PhD right now. So I think it will be very good or very nice also for him to know that his work is more visible in some place, and even if it's reused by some other people. No, that's very good when you have the feeling that your job is going to be used by someone else after 4 or 5 years doing the PhD.
Yeah, cool. Let's follow up on that. We can kickstart that. Let's do that later.
A question to Dor: are you going, or is there any plans to update the SWF format?
No, I mean,
Okay.
as I mentioned, I'm actually not really working on this field anymore. I sort of shifted to software engineering issues and program comprehension in the last few years. So, and I don't have any students working on this. So I very much welcome updates like what Julita was suggesting. My only reservation, it's not really a reservation, it's a sort of worry, is that I mean, the benefit or the advantage of the SWF was that, as you said, it's very simple. And even that, we included things that ended up not being used. For example, I don't think anybody ever used the two last fields, which are the dependency and the think time, which was indeed intended to enable sort of incorporating data about the user behavior and workflows in a very, very minimal and simple way. And obviously, that was 30 years ago, and even then it was too simplistic. So obviously now there are much more complicated workflows and job structures and dependencies and possibilities in Slurm and in other scheduler systems. So that you would like to add that. My only worry is where do you actually get the data to populate all of those fields, and will you really have enough data and real data that people will actually use to both in terms of supplying data, workload files with data that uses all that, and then that they know what to do with it. And the more fields you add and the more types you add, the worse the problem. But I think that what Julita was suggesting was really relatively minor. So it's not a huge thing. It's just mainly more types of dependencies. And I mean, I don't really have first-hand experience with this because I'm an academic and I used to do simulations about scheduling in very simple ways. I'm not like, I mean, you're from BSc and Dalibor has his installation. And all of you, some of you have real experience with real systems. I don't. So your real experience is trumps. That dictates what are the real considerations that need to be taken into account.
I think your experience is really valuable.
Let me draw that our system is using your papers in everyday operations, so your thoughts and your discoveries. As I said last year, I think I always discovered some new thing, and I said, okay, this is great. That's my idea, and then I realized that you have found it 10 years ago. So.
Don't forget,
it's time that you find things that I didn't find.
Okay. I also think
I hope you will.
The success of the PWA is it's very simple and a generic solution. So if it's getting complex, so people might switch to other simple solutions. I even thought of, for example, for me, it was always important how much I/O a job is doing, and this is also not mentioned in the But there is one log that I now know of, the Gaia cluster that has a companion log. I also thought of maybe something similar, that just adding a field that there is a companion log for that job would keep that SWF very simple, and you can add a second log to it where you have more details about the job. That could be a solution probably for it.
Yeah, but it would be nice to have some, so that it doesn't change across different logs, this companion.
So the SWF would keep as it is. It would be simple. And for example, if someone is not interested in the additional information, just wants that rectangle CPUs over time, so he could just stick with the SWF. Yeah. So there is need to also the GPUs that you mentioned before. Yeah, we also need to simulate how the GPU usage is in a cluster, but there is no feel for it. But that could be done with a simple companion log that just adds for every job ID that it's another requested field would be available. So we wouldn't change SWF a lot.
But the proposal is just to add few extra columns. I mean, it's not more complicated. In the same way you parse 12 columns, you can parse 20 columns. I mean, it's a simple parser with the same format. It's true that it's an extension, but there are things that are really, really common in all the data centers. So, for instance, I think in the proposal there was nothing about input-output. And when you were saying, I was thinking, it's true, maybe input-output, there is nothing in the output. So it's a good comment. It's true that we cannot incorporate everything, because then we will have 1,000 columns, not 20.
Right. So it would be useless.
Yeah, I totally agree with you. And for instance, we are using runtime metrics that they are not in the, it's not my proposal. So we have a separate file with that. But I do think if things that are really, really common today, it will be good to have in a standard format or in a common agreement, because otherwise we will have again one standard and then different formats for information that are really, really standard. Because I think for instance, the case of GPU for me is the more clear, because it's something that is widely included in I think all the data centers in the world right now has GPUs. So it's just an example, no? But energy, for instance, is an important topic, and there is nothing, energy or power, there is nothing in the standard workload format. We can have it in a different file, yes, but I think we will all agree that is something that is every time more relevant, and it will simplify if it's in the same parser, in the same file with an standard. It's difficult to have an agreement in 20 minutes right now, having a discussion, of course. I don't know how we could proceed if you agree that extra columns or extra fields could be added, because maybe the proposal will, at the end, will be a paper and nothing else. I don't know. But if you think that it has sense to add some columns or some fields, I am open to sharing some proposals, some documents, and to have some additional discussion in another moment. It's up to you. If you don't have time or you don't want to open that discussion, for me, I mean, it's okay. We will extend the standard workload format for our simulations, and it will be something more local for us. But if you think it's a good moment after 30 years to add some common agreement in some of the columns, I am open for changing, for having some mails or something to do a proposal. So it's up to you, when you now is the community or the group.
It was don't understand me wrong. I'm totally fine that things have to change, but just don't want to make it too complicated. It's okay.
No. I agree with you. There are things that I have not included because there was too specific for our research. But if you think it has sense to do a review, so it's up to you, Dalibor, Gonzalo, Alfredo, Dror. I mean, maybe you, Dror, you don't want to spend your time, no? You it was clear. But if you want to have some mails citing the format and making a new proposal, it's okay to me. And if you don't want to do it, it's also okay.
Yeah, the best of all of that is that we are going to use that to bring Dror back there and come back. Right.
Yeah.
But like I'm so sorry when my jokes do not work. But
no, because your line dropped for a second, so we had to second guess what were you saying actually.
Sorry, I was inviting Dror to come back, that he's needed in the community. But I think we should move forward and find a way to extend the work that was done in the archive, to put more things, because it's really important. I mean, the base of science is for people to be able to check each other results and collectively learn, based on what already happened. Like, reinventing and repeating things is not particularly useful as a way to gain progress. So let's do the following. Maybe me, Dalibor, Gonzalo, Narayan can discuss this a little bit, and we send an email to everybody on a suggestion on how to proceed. Because there are a few things that, and I think the key here is to keep the process lightweight. Everybody's busy and has a trillion things to do. We should be able to do very simply, just add a session in the site to put links to whatever is open source. As Julita says, this has been open source for a while, but visibility is high. And I think it's also possible for us to start a discussion. Now we are using Slack to collaborate, and we can have a mailing list to keep very simple discussion on how to extend the format with a little bit more information in a way that is simple. So I think it's worth a little bit of discussion, but let's keep the process simple and let's iterate on it.
Yeah.
For me, it's perfect. This is why we make the proposal, because at least we have something to discuss if you want.
Okay, great. Let's follow up on that.
Yeah, I can promise that I can, if the extension is simple, I mean GPUs and some job topology, I can provide some real-life data from our system, because that's what I'm doing. And some of those workloads with these extra things are already in Dror's archive. I mean the original data. So it would be very easy for me to generate some first real-life based data from our system. No big deal. I agree. But we should move to another talk. Very nice discussion. Thank you for that. And the next speaker is Fred, and he will be presenting paper on